Okay, class, we're going to begin a new unit today dealing with what we call algebraic expressions. So the first lesson of this is learning to read and write expressions. It's a very, very important skill. Okay, so let's start off with looking at a couple of things here. Okay, this is a little chart that details or talks about the different types of sizes of vehicles and how many miles per gallon they get. It says how many miles can you drive on 10 gallons of gas? It's the basic question. The answer depends on the type of vehicle you drive. This table shows some typical data. Subcompact, which is kind of a small car, 330 miles on 10 gallons. So that's pretty good. It's getting 33 miles to the gallon. It's not bad. A compact, a little bit bigger car, not much bigger, but a little bit bigger. They only get 300 miles for every 10 gallons. They do, okay, because it's a little bit bigger, a little bit heavier, less miles to the gallon. Mid-size sedan, 240 on 10. Sport utility vehicle, 175 on 10. Pickup truck, 160 on 10. Not too bad, okay? If it's my truck, I get about 100 miles for every 10 gallons because it's a little bit bigger truck. Four-wheel drive, things of that nature. Well, these are what we call numerical expressions because they're just based on a number. But you'll notice that there's one number that keeps changing, and that's the number of miles for the type of vehicle that we have. The gallons always stayed the same, but the number of miles didn't. Okay? So we could actually turn this into a variable expression, where these are what we call numerical expressions because they're just straight numbers. We could write this as a variable expression. Okay? If you don't know the number of miles, you could use a variable to stand for the number. Then you can write a variable expression for miles per gallon, where the variable would be m, okay? And the variable expression would be m divided by 10, because we always dealt with 10 gallons, okay? And we would actually write that, instead of using the little division symbol, we would actually write that as m over 10, because in algebra, we're not going to use this division symbol anymore. So again, a variable is a letter that stands for a number, and we've dealt with these variables quite a bit as we've been working with our equations. And anything that has a variable in it is considered a variable expression. Now, the big difference between the ones that we're dealing with now and what we've dealt with in the past is an expression doesn't have an equal sign in it. What we've been working with are equations and inequalities, and there's two sides to that. Well, when we're dealing with expressions, we're only dealing with one side. Okay? So let's see if you can determine, what's a numerical versus a variable expression. Okay? So in this particular instance here, it says identify each expression as numerical or variable. A, what would that be? Numerical, very good. It's just straight numbers. B, good, variable expression. It does have a variable in it, so it's considered a variable expression. Let's try a few more. Okay, this first one, good, variable expression. The second one, numerical expression, that's correct. And the last one, variable expression, that is correct, because we do have a letter in it. Now that we understand the idea between a numerical versus a variable expression, let's learn how to write them. Okay? So what you're going to do is it says you can translate word phrases into variable expressions. And that's what we want to try to do. Take these word sentences and translate them into math. Okay? So when you're dealing with algebra, you're really dealing with a brand new language. Okay, it's the language of algebra. And you have to translate these things into expressions. And we've done some of this before, and when we dealt with equations, so it shouldn't be anything new. There are a few nuances that we really have to pay close attention to. This first one says, 9 more than a number y. Okay? Well, 9 more than means that I'm going to take this 9 and I'm going to add it to something. Well, what am I adding it to? I'm adding it to y, because it says I need 9 more than that. Okay, so the way we would write this is y plus 9. 9 more than some letter. Okay, so be very careful when they say 9 more than. It's not 9 plus something. It's something plus 9. Okay, here's the same kind of thing in this one. It says 4 less than a number. Well, in order to determine 4 less than something, I have to know what the number is first. So in this one, it's going to be n minus 4. Okay? A number z times 3. Now this is the only one that there is a specific way of writing it. You always put the coefficient first. Okay, the number with the letter. Now they gave us several options here, but the one that is correct is going to be this one here in the middle, 3z. That is the one that is the most correct. A number A divided by 12. Okay? Well, divided by, we're going to use a fraction. So this one right here is not going to be acceptable anymore. It's still correct, but when we deal with algebra, we want it to be in terms of a fraction. So a number A divided by 12 is going to be A over 12. Now here's one that's a little tough. It says 5 times the quantity, 4 plus a number C. Well, we need to understand that this word quantity means parentheses. It says whatever comes after me, put it in parentheses. Okay? So 5 times the quantity 4 plus a number C. So 4 plus a number C is going to be 4 plus C. It's not going to be like this one up here where we did more than. This one actually says 4 plus C. Okay? So we write it as 4 plus C. That's going to be in parentheses. Now this times 5, we're going to put it right next to the parenthesis. So we would write it just like this. 5 parentheses, 4 plus C. And that means whatever's on the inside, I'm going to multiply it by 5. So this dot right here, when we put the times there, it's basically just being redundant. If you put the 5 right next to it, it also means multiply. So let's see if we can actually do a few of these on our own. Okay? So here are a few word phrases that I would like for you to translate into an expression. So pause the video and try these, please. Okay, let's see how you did. Okay, in this first one, it says 5 more than R. Well, the 5 more than means I'm going to add 5 to the R. So this should be R plus 5. Now, some of you are going to say, but Mr. Nash, isn't 5 plus R the same thing? Yes, okay, it is. But if I were to say, go over there, and I were to spell the word T-H-E-I-R, did I spell it correctly? No, it sounds correct, but I didn't spell it correctly, because go over there would not be that correct there, okay? Or if I said there's 5 plus 2, and I wrote the word T-O-O instead of T-W-O. Still sounds the same, still, acts sort of the same when you say it, but when you write it, it's something totally different. So we have to spell these correctly. Okay? K times 3 plus 8. Okay? Well, K times 3, we know when we're multiplying, the 3 always goes first. So that's going to be 3K, and then it says plus 8. So 3K plus 8 should look just like that. The quotient of G and 4. Well, quotient is a word that means division. Okay? And anytime you hear one of these words, quotient, difference, and sum, okay, you take the things in the order that they appear, and the and tells us where the mathematical symbol is going to go. So in this case, it says the quotient. Okay, I'm going to be dividing. Well, what am I dividing? G and 4. So we put it as G over 4. Okay, the difference of 9 and T. Again, difference means that I'm subtracting, and the and tells me where I'm going to put the subtraction sign. So the difference of 9 and T, 9 minus T, just like that. Okay. Now, can you go the other direction? Okay, can you go the other way? Well, what if I gave you the expression, could you write it in words? Well, this is where I want you to use what we call the KISS method. Okay, and basically that means keep it simple, stupid. Now, I'm not referring to you as stupid, but that is a method that we're going to use. Keep it as simple as possible. Okay, don't try to get real fancy with your words. Just say it exactly as you see it. Take, for example, this first one. We've got an X, we've got a plus, and we've got a 6. So you'd write that as X plus 6. Now, are there other ways of writing that? Yes. 6 more than X. The sum of X and 6, all those are correct, but it's easier just to say it exactly as you see it. Like this next one. Write this one as 3 times C minus 8. 3 times C minus 8. The next one, 10 plus H. The next one, now the easiest way of doing this one to show parentheses is actually to use a comma. Just like solving this kind of a problem, start in the parentheses. We would write this as M minus 5. And then really the way to show parentheses is put a comma. It means get an answer to all the stuff in the front, pause, and then do the rest of it. Times 3. Okay, and then the last one is n divided by 2. Simple as that. Right? Now, could we use this in the real world as well? Yeah, here's kind of an example. Okay? The fastest dinosaur may have been this one right here, the ornithomimimus, something like that, which could run about 60 feet in a second. Write a variable expression for the distance this dinosaur could run in a given time. Well, the variable is going to be our seconds because we don't really know. But I know however many seconds it is, if he can run 60 feet every second, we know that that would be 60 times a variable s. And then the way we would actually write that is 60s. Okay, now, no matter how many seconds we have, we could determine how far they ran. Okay, so same kind of thing. 60 represents our number of seconds. S stands for the number of seconds. We write it as 60s. Okay, let's do a couple more and then we'll be done. Okay, this one says, bagels cost 50 cents each. Write a variable expression for the cost of B bagels. Well, I don't know how many bagels that we have, but I do know they're 50 cents a piece. So the 50 is what I know, and I don't know how many bagels, so it's just 50 cents times B. And notice 50 cents, 0.50, or just 0.5 will work. Okay? Write a variable expression for the number of hours in minutes. Okay, now, if I'm given minutes, however many that is. Let's say it's 60 minutes or 120 minutes or 5,242 minutes. Okay, that's my variable. But I do know for however many minutes I have, if I want to convert that to hours, I divide that by 60. Sorry for that. I don't know what that's doing there. But I divide it by... I know I divide it by... I divide the m by 60, and I'll always get hours. Sorry for that little mess up there. My computer was kind of messing up. Now, what I'm going to have you do for your assignment today is do both of these kind of concepts. I'm going to give you some phrases that I want you to translate into algebraic expressions. And then I'm going to give you some algebraic expressions that I want you to translate into words for me. Okay? So it's just simply translating back and forth. Okay? So to read and write, you just know that some of these words, they mean various things. And in order to get correct, in order for you to get the correct answer, you have to be able to spell it correctly. So pay attention to the way the words are phrased so that you can put them together correctly. Until next time.